This is a video for my Arduino project in INTC 1085. The first thing we're going to look at is how I set this project up. And to do that, I will be using a program that's called fritzing. It allows you to wire things up in a computer simulated environment. So these are all the components that we use. In the long run, this is what it's going to look like in the bottom left here. So first we're going to move the LCD display down to the bottom right corner. And our piezo buzzer, just going to leave it right there. And our potentiometer, a 10K potentiometer, put it right next to the piezo speaker. And our thermistor, which is what we used to estimate the temperature as well as the necessary resistor. And of course, we use the regular Arduino board. So first we're going to do is we're going to wire up our power. And I made all of my power cables red, because red normally means hot. I goofed in my video, but I did change it eventually. So of course we're going to keep our cables nice and organized. Like I said, I would change the color eventually. This would be that time. Now we're going to also wire up ground. Ground wires will always be black. And I get this color right this time. And of course we'll keep things organized, so we'll pull the cables out of the way here. We're also going to bring our ground and power down to the bottom row here, because we do use that for the piezo speaker. And it's also a good practice to do that, just in case you need to jump down there for power or ground. Again, ground is black, power or hot is red. Those are 5 volts in this case. So now we're going to go ahead and give the potentiometer power and ground. So of course we're just going to go straight up. We're going to make sure our wire colors are the same. Red for hot, black for ground. As I said, I goofed. The ground is supposed to go one more above where it was. And the first couple pins for the LCD, the first one's going to go to ground. The second one's going to go to our 5 volts in. And then our first pin for the thermistor is going to go to the 5 volt input. Then our 5th pin for the LCD is going to go to ground. Our 5th pin is also the RW pin, the read or write pin. And if we put it in, or if we connect it to ground, that makes it in permanent write mode, which I will explain that a little bit more as the video goes on. And we will make sure the ground for the piezo speaker is connected, as well as the other side of the resistor going to ground. And one more ground connection we have to make. It's the 15th pin for the LCD. Alright, so now we're going to set the middle pin of the potentiometer to the 3rd pin on the LCD. All it does is it just controls the contrast of the screen. If we want it darker, we turn the potentiometer up. If we want it lighter, we turn it down. Very simple. And now we'll connect the red wire to the piezo speaker to the 7th digital input pin. And we'll make that one orange. And of course I goofed again. The orange wire is supposed to go to the red wire on the piezo speaker, not the black one, but you get the idea. So now we're going to look at the 16-pin wire out for the LCD. Now, like I had showed you earlier, the first pin is ground. That simply just goes to ground. Next pin goes to our 5 volt input, VCC. It's a fancy way of saying the power coming in. Then the VO, which is our third pin, that is a potentiometer to control the contrast, as I explained a little bit there before. Then I haven't wired it up yet, but RS, that stands for register select. That tells the LCD if we're going to send it a command, as in clear the display, or a character, as in hello or hi. And then our RW pin, which is our 5th pin, the one that we connected to ground, this is the read or write pin. This pin gives instructions to the LCD, and it reads info from the LCD. Now the liquid crystal library file that we imported in our code, which I will be showing you in this video as well, it's a little bit intelligent. So if we put the read-write pin to ground, it makes it in permanent write mode, and the liquid crystal library has enough delay to where we wouldn't have to switch it between read or write. We can just keep it on write, and then the delay that the liquid crystal library file puts in it is enough to keep it working. And now the D0 through D7 pins, those are the pins from which the binary equivalent of the commands or characters are sent through. But in this video, or in my project rather, I only used pins 4 through 6, or 7, correction. We'll be sending our commands or characters in a form called a nibble, which is half a bit. This just helps to keep the Arduino board pins freed up, just in case we wanted to add any more things to this project. And then the A is anode, which we sent that one to ground, and K is cathode, which we didn't do anything with that because we didn't need to. So now let's go ahead and wire up the LCD. So first we're going to start with the pins, the D7 pin on Arduino, our LCD, and we're going to go to pin 2 on our Arduino board, which is our digital pin, I might add. Of course, we're going to move the wires over to keep it all organized so we can tell easily where the wires are going. And then pin D6 on our Arduino, on our LCD, is going to go to pin 3 on our Arduino board. D7 is also the equivalent of pin 14 on our LCD. And just steps back as we go. Now we're going to put pin D5 from our LCD. We're going to put it to pin 4 on our Arduino board. And last but not least, we're going to put pin D4 from our LCD, and we're going to go to pin 5 to our Arduino board. Now that is our quote-unquote nibble portion of the pinout. Now we're going to look at the register select pin and the enable pin. First we're going to connect our enable pin. That's the pin to the right of the ground wire we see there. That's going to go to pin 11 on our Arduino board. And then pin 12 on our Arduino board is going to go to the register select pin, which is the pin to the left of the ground wire. Remember, our register select tells our LCD if we're going to be sending it a command or a character. And last but not least, we're going to be connecting the ground pin of the thermistor to analog pin number 3 on our Arduino board. And we're going to make this one white just to distinguish between everything else. One of the very convenient things about fritzing is after you're done, you can print a diagram of the breadboard, so we can just put it on your actual breadboard and you can pin things out very easily. So of course we're just going to go to File, Print. I'm going to make a PDF of it just so you can see. But this is exactly what the printed version will look like if you were to print it. So you put it on top of your breadboard and you know exactly where to put the pins. So now we're going to look at the code. This is actually what made the project work, and I had a little fun with this. So the first thing you see is the include file, which is a liquid crystal library file that has all the commands that we will be using in this project. Of course, the second line of code initiates the LCD, and the pinout is very important here. You see 12, 11, 5, 4, 3, 2. 12 was our register select pin, 11 was our enable pin, pins 5, 4, 3, and 2 were our pins D4 through D7 on our LCD. Then the constants you see there are the pins where each of the other devices are located, like our thermistors on pin 3, our buzzers on pin 7. And I forgot to take the button pin out, we don't have that anymore, so you can disregard that. Then we have our value variable, which that just holds the value for the temperature that we gather from the thermistor. And then we have two more constants, delay between screens and alarm delay. Pretty self-explanatory values. I'll get in a little bit more detail as we go on about how those are working in the code. And then the custom character for the degree symbol. I actually found this little part on YouTube. It was very cool, I thought. You can actually make your own custom character. You store it into an array, and then you call it later on in the code, which I will point that out, of course. So in the setup portion of the code, we begin the LCD, which that specifies how big the LCD is, in our case 16 by 2. Then it clears anything that could be left on the LCD. And then the next line of code actually makes the LCD aware of the custom character that we will be using. And then the next 3 lines you see are the pin modes, and that just specifies whether each specific device we have connected to the Arduino board will be input, or output. In this case, our thermistor will be input, and our buzzer will be output. So now we're going to look at the void loop portion of the code, and this is actually where everything is going on. So you can see our first line of code sets where the cursor is going to start, which is the top left position, and that prints wake up. And then the next lines of code that you see create a pattern very similar to a alarm clock, and this is how that looks. And then the last line of code we see on the screen, lcd.clear, that clears the LCD screen in preparation for what is getting ready to be printed on it next. So our next section of code actually displays a greeting and scrolls the message across the screen. So the LCD set cursor, that puts the cursor in the very first spot on the LCD. LCD print will print the message, "Good morning, Zach." And the for loop we see here actually scrolls the display from right to left for each specific character, because that's how we have to set it up. And of course have a delay in between, so it doesn't go all by just like that. And this is how that looks. And the next line of code is a subroutine that waits a couple seconds and then clears the screen for the next portion of the program. And we can look more into this subroutine at the end of the program, end of the code rather. And then the next set of code that we see displays the temperature, which is a very, very rough estimate, just the concept more rather than accuracy right now. So of course we're going to set the cursor in the first spot. We're going to print the temperature, and then we're going to set the cursor on the next row. We're going to print is, and leave a colon. And the next line will store the value of the thermistor into the variable called value. We're going to set the cursor to 4 and 6, which is just right next to the space after the is, and that it prints the value, -84. Don't ask me how I got that number. That's just a number that I found to make it feel like it was about room temperature in the room, which it felt like it was, maybe a tad bit cooler. Then after we read that value from the thermistor and stored it into the variable, we printed that to the screen. And then we set the cursor to right next to where the temperature would be displayed. And this is where our custom character comes in. we do lcd.write, and then in parentheses we put 1. Notice it's not print, it's write because we're using the custom character. Then we set the cursor just to the right of where we put our custom character, and then we print Fahrenheit, or the letter F for Fahrenheit. And of course we see the delay again. The next screen will display the date. Very self-explanatory. Set the cursor to the base spot, but today is, go to the next line, and then put the date. And then for our final set of code here, we display some sort of news headline. Of course, we're going to start by setting our cursor to the home spot. And then we print, breaking news, Arduino has arrived. And the for loop you see here, this is very similar to the one we saw before. Actually, it's the exact same thing, except we change a couple numbers. The breaking news, Arduino has arrived, scrolls across the screen. And then at the end, the display blinks to make it kind of seem like it's popping out to you. And we can look at that right here.
Or if somebody told you had to take 16 teams, would you rather do it all on their own or mix?
So now we're going to take a look at the void delay clear subroutine. All this does is it delays the delay between screens, which was 2 seconds, which we had to enter as 2000. This is all in milliseconds, and then it clears the screen. And then the second subroutine that you see right here is the alarm beeping pattern. All it does is, since our piezo speaker was plugged into one of the digital pins, we had to use digital write. What it does is it turned it on, waited for the alarm delay, which is about 150 to 250 milliseconds, I cannot remember, and it turns it off. That's the one beep you hear, and the next one beep, and the next one beep. So beep, beep, beep. And then we repeated that 5 times. So after all is said and done, let's take a look at our final result. This concludes my video for my Arduino project in INTC 1085. We'll see you next time.